Hi everyone, today we're going to be learning about mathematical induction. What is mathematical induction? Well, mathematical induction is a method of mathematical proof typically used to establish that a given statement is true for all positive natural numbers. Now what could this be used for? Well, induction is used to prove mathematical statements for all integers, not just ones that you choose. Let's look at an example, shall we? So, if we wanted to prove that the sum of all the powers of 2 greater than or equal to 0 is 2 to the n minus 1, first we would write out our statement. So we have 1 plus 2 plus 4 plus 8 all the way up to 2 to the n minus 1 is equal to 2 to the n minus 1. Now, how would we go about this? Well, we could just pick a bunch of random numbers to see if it works, like maybe n equals 3, or n equals 6. And we could just continue picking random numbers, but this would not prove that the statement works for all numbers because there could be numbers outside of the numbers that we've picked that don't work. This is where induction comes into play. Now, induction is a very particular type of proof, and we have to follow the steps very carefully in order to do it properly. So, the first thing we're going to do is we're going to write our statement. Proved by mathematical induction that 1 plus 2 plus 4 plus 8 all the way up to 2 to the power of n minus 1 is equal to 2 to the n minus 1. Then we get into our steps. So step 1. First, we have to prove true for n equals 1. So we're going to take the left-hand side of our statement and let n equal 1. As you can see, this is equal to 1. Then we take the right-hand side and we do the exact same thing, and we see that this is also equal to 1. Therefore, the left-hand side is equal to the right-hand side, and we've proven true for n equals 1. Step 2. We have to assume true for n is equal to k. So we're going to take our statement and we're going to sub in n equals k. Simple as that. Now we've done with this step, we go on to step 3. Prove for n equals k plus 1. This step is a little bit more confusing and starts getting a little bit complicated sometimes. So we write out our statement and add the next integer. Now, as you can see, we have the assumption, and then on top of that, we also have the next integer. Now, of course, we're going to take the left-hand side, and as you can see again, we have the assumption, but we can swap it out because it's equal to 2 to the power of k minus 1. Then we're going to simplify this, and when we simplify it, we see that it's equal to the right-hand side. Therefore, we've proven by mathematical induction. Let's look at another example, shall we? We can also use mathematical induction to prove divisibility. So, we're going to prove by mathematical induction that 5 to the power of n minus 1 is divisible by 4. We're going to use the exact same steps as before with a little bit of tweaking. So, step 1, we're going to prove true for n equals 1. So the first thing we're going to do, we're going to take the left-hand side and we're going to let n equal 1. Now, as we can see, 4 is obviously divisible by 4. So we've proven that the left-hand side is divisible by 4, and this is true for n equals 1. Step 2, we're going to assume true for n equals k. We take our statement and we have to write it out properly now. So 5 to the k minus 1 is equal to 4 times any other number. Step 3. We now need to prove true for n equals k plus 1. So we're going to write out our statement, but we're going to swap out m for q because they're not going to be the same number. Now we're going to take the left-hand side and we're going to simplify this. Simplifying this is going to show us that if we rearrange our assumption, we can actually see that it equals 5k, shown here. So we can now use our assumption and sub it into our equations to simplify the statement. And then we see that it's all divisible by 4. Therefore, we've proven by mathematical induction. I hope you've enjoyed this lesson, and hopefully now you feel comfortable enough to go out and do some harder questions of your own. Have fun!